I'm going to be talking about some ways of minimizing the impacts of saltwater inundation. I think that's really all we can do is try to minimize the impacts. We can't completely solve the problem. Sea level rise is occurring. It's going to be occurring for a long time now. We're going to have to learn to adapt. We're going to have to learn to think outside the box, I think, for some of our crop production, maybe change up the crops we use. Of course, that's going to involve developing markets because obviously a farmer's not going to grow something if they don't get some kind of income from it. So a lot of what I have to talk about today is not so much production crops, but more conservation-related crops, plants that help solve natural resource problems that may have potential to bring income, but it's a matter of developing those markets. So back in 2014, NRCS had a vulnerability assessment and adaptation plan. I think that was the last one that NRCS did. But in that, they recognized that coastal storms are going to increase in frequency and intensity, leading to greater storm damage, wave heights, coastal damage, coastal flooding, etc. And that the sea level levels are predicted to rise over the next 40 years or so, maybe even longer if we don't control our greenhouse emissions. But the resulting impacts from that would be increased salinization in near coastal waters, which is happening on a relatively localized basis, but it's actually happening at a greater extent here in the mid-Atlantic, from about southern New Jersey all the way down through the Carolinas and into the Florida and Gulf Coast, the worst areas of the country as far as experiencing sea level rise and impacts to agriculture in particular. So it's going to result in changes in plant adaptability. So plants are going to have to change. Climate's getting warmer. The southern plants are migrating naturally further north. Some southern plants that we weren't able to plant in this area, say 30 or 40 years ago, we're able to do now. So that may provide some opportunities actually for us. Increased competition from weeds and invasive plants, like Phragmites, for instance, and other weeds, Johnson grass, crabgrass, all those nasty agricultural weeds. And then, of course, increased soil health challenges due to the increased potential erosion and changes in the chemical and biological processes which occurs with saltwater impacts, intrusion. So about the same time that report came out, the USDA climate hubs were established, and I just wanted to make you aware of the climate hubs because even our own folks aren't even fully aware of what the climate hubs are. But Secretary Vilsack, U.S. Department of Agriculture Vilsack at the time, had the brainchild to establish these hubs, and they were intended to be sort of a clearinghouse of climate information, climate-smart solutions. The idea was to combine efforts of multiple federal agencies and work with partners, work with academia, work with Extension Service, and create this network that we could feed into information to help solve climate problems. So the primary structure of these climate hubs is the Forest Service, ARS, and NRCS are the three federal agencies that provide most of the input to the climate hub structure. And NRCS is more of a supporting role from a technical standpoint. Most of the hubs are actually directed by U.S. Forest Service or Ag Research Service. I believe there are 10 hubs nationwide, and I was fortunate enough this year to work with two of the hubs on this saltwater inundation to be able to study this saltwater inundation issue. I worked with the Northeast Hub, which is based in Durham, New Hampshire, and that's a Forest Service office, and I also worked with the Raleigh, North Carolina Forest Service office, which is they direct the Southeast Hub. So this year was the first year since the climate hubs have been established that they actually focused on this issue of saltwater inundation. Prior to now, it's been mainly dealing with soil health issues, improving soil health, cover cropping, irrigation type of related activities, and that sort of thing. So I had the opportunity to actually work and study on this issue with the climate hubs. So they recognized that we had the vulnerable agriculture in coastal areas. This happens to be down in eastern North Carolina, which is basically a hot spot in North Carolina for this issue. Forest land was cleared back in the mid-1970s, and these series of drainage ditches and canals were installed to drain fresh water from the fields. But now they're serving as conduits for saltwater to come further inland because of sea level rise. and more intense storms. One thing they do here is in Hyde County, North Carolina, the Conservation District, I believe, has a cost share program on installing floodgates and improving floodgates and that sort of thing, which is an engineering solution which, is expensive and, and it's going to have a shelf life of some sort. In southern New Jersey, we're actually experiencing issues along the Delaware Bay. There's a sod farm that has been experiencing saltwater inundation and reducing sod production more and more every year. And we made site visits and talked about what some potential options that this producer might have, which hopefully we can follow up on in the future. This probably isn't the most economical solution, and if anyone was sitting in on Danny's talk prior to this, this was the protect sort of strategy, and I'm not going to talk much about protecting either because it's engineering, it's expensive, but in the Netherlands they have quite an extensive network of dikes that that protect their ag land and protect structures. These are not high biological diversity. I mean, they plant grass on these things. They graze them with sheep. They don't want woodies to come in because that'll disturb the integrity of the dike. So there actually is a movement now to strategically identify areas where they will actually remove the dike and actually install dunes in some cases if it's right along the coast, or if it's in an area that's more wetland oriented to restore some tidal marsh. So, so they're actually moving away from maintaining these dikes to, they're maintaining them quite extensively actually, but there is a movement to try to look at more of a restoration aspect of dealing with the saltwater inundation. So, plants, I work with the plant materials program. So, plants are obviously a more cost-effective means and more adaptable, more resilient means of dealing with this issue. And I just pulled this from Maryland's Adaptation website on climate change. And, things like selecting plant species that are tolerant to salinity changes, of course, and increased temperature. Also, planning for migration, planning for marsh migration, which Danny also mentioned in her talk about, allowing some, if these areas are flooding frequently, allowing them to revert back to wetland systems. And then maintaining and enhancing diversity of plantings to help with changing salinity. And so the diversity aspect is very important too. Not just planting monocultures or something, but having a diversity. So there's opportunities to plant mixed stands of warm season grasses and pollinator plantings and things like that, which would be considered like a multifunctional type planting. So at the Plant Materials Center, we work on these issues. We've been around since 1965. We service southern New England and the mid-Atlantic states. Our prime focus is coastal shorelines, critical areas along the coast, and selecting and developing plants for coastal restoration. So, in addition to studying these coastal plants, we also work with plants that are adapted to the coastal plain site conditions for farming applications and things. So low nutrient, very sandy, very droughty soil conditions. We're located about 15 miles north of Cape May Point. So, and we're sandwiched between, we're right near the Great Sound, which is behind the barrier island of Stone Harbor, Avalon. We don't have access to salt water on the facility. The pond is freshwater, groundwater fed, but the marsh you can see is right on the other side, on the east side of the Garden State Parkway. So we're close. So we have a lot of opportunities for plant evaluation on actual problem sites, actual saline sites or coastal sites. Just an example of a product we selected from the Upper Chesapeake Bay that has application for riparian buffers and things, but just to kind of explain how we do our work. This was growing in near Port Deposit where the 95 bridge goes across the Susquehanna, just south of there. It's pure freshwater. Obviously, it's not, the pressure range isn't that high in the bay. It's all freshwater coming from the Susquehanna. But we, by accident, we discovered that it had pretty good salt tolerance. So we actually did some plantings in a back bay right behind Stone Harbor where the salinity was pretty brackish, high brackish on the high side. And this particular material didn't blink. It didn't seem to be affected at all by the salt water. So that led us to believe that are there other species out there that that we don't recognize, that they do have some inherent salt tolerances that we're not recognizing. We already realized that switchgrass had a very high range of salt tolerances because we see it growing in the on the upper edges of the tidal marshes. We also see it growing in freshwater. We see it growing in pure sand. So it has a high range of environmental site conditions that it tolerates. But so based on this, we're going to take it. We've started a process or a project where we're going to take a look at other plant species and see what their upper level of salt tolerances are. And we use this as a model. We don't do selective breeding. We do selections. So we basically take what nature's already produced, collect materials in the field of whatever species we're interested in working with, and do comparative evaluation and observation. And then the material that meets our criteria, we actually select for release to a commercial marketplace or for doing projects. And as it turns out, a lot of the saline agriculture work that's done around the world there is some breeding work being done, but a lot of it is this very same concept. It's comparative observation. It's basically taking existing varieties and germplasm of existing food crops and exposing them to different levels of salt and seeing which varieties actually can tolerate higher levels of salt, because a lot of these varieties have never been exposed to salt. So, for example, I'll use the Netherlands as an example again. They found tomatoes, potatoes, cabbage and kohlrabi, and I think some strawberries that were varieties that already existed. They found that they tolerated like moderate levels of salinity, but it was just a matter of testing for it to see if they would tolerate that. And also, they're willing to accept somewhat of a yield decline. Obviously, you're not going to get 100% yield on something, if you have moderate salinity, but somewhere in the range of 85, 90%, they're using as a threshold. So it was interesting to see that model, held similar to how we select conservation plants here in the United States. So just a little bit, I just threw this together kind of at the last minute, but just thinking about when we talk about salt tolerance in plants, different plants and different groupings of plants react differently to salts. For example, the halophytes, which are the plants that grow in pure salt water, actually incorporate salt water into their tissue. And they have glands that exude salt, to allow them to survive. So those tidal marsh plants, like the Spartina, the Salicornia, which is the glasswort, the succulent that grows in the tidal marsh, which is a very important plant actually worldwide, and I'll talk about that in a little bit. Disticulus, saltgrass, these plants grow in pure salt water and don't have any problem with that. Then there are other plants that will tolerate, they don't like it necessarily, but they'll tolerate various levels of soil salt, as well as saltwater flooding. So you kind of have to parse out the tolerance to flooding and the tolerance to the salt in the soil, because not all plants will tolerate both. But things like our native warm season grasses, like eastern gamagrass, coastal panic grass, switchgrass, all tolerate both some level of saltwater flooding as well as soil salt. They don't necessarily like to be standing in saturated soil conditions for a really long period of time, but they can tolerate the flooding. And those species actually are already also adapted to drought. And then there are some plants that will tolerate soil salt but not tolerate flooding at all. Some turf grasses, some vegetable crops, like I was just talking to Bob over here about asparagus. Asparagus is a very salt-tolerant vegetable crop. But it will not tolerate flooding, or tolerate salt in the soil. Many small grains like barley. Again, barley is very salt tolerant, but will not tolerate much flooding, and sorghum Sudan grass. And then you have some plants, like some of our dune plants, that don't want to be growing in water or wet soil. They want to be growing in pure dry soil, and they have adaptability to salt spray. And we actually have a vineyard manager, or actually owner, in Cape May County that says he's right along the Delaware Bay. He says the salt spray actually imparts a unique taste to his grapes, to his wine. So he's looking at it from a positive standpoint. He was also flooded in Hurricane Sandy, Superstorm Sandy, in 2012, but because it was late October, early November, his vines weren't impacted by the flooding because the vines were dormant at the time. So timing of flooding is also very important. So all these things come into play. As far as mitigation versus adaptation, I'm going to be talking mostly about adaptation, but mitigation is like a short-term solution to lessen the damage of something. I visited a couple cranberry growers up in Cape Cod back in the early summer. And only a couple of them there actually experienced coastal flooding into their bogs. So it doesn't happen very often, but when it did happen, they got the recommendation, I think, from the local extension agent up there to apply gypsum. And gypsum, and because it was a cranberry bog, they also had irrigation, so they were actually able to apply gypsum and then flush the system, flush the soil, because what happens when you apply gypsum is you have the calcium replacing the sodium on the exchange sites. Of course, sandier soils don't have a lot of exchange sites. Anyway, so you need to flush the sodium away, or the sodium's still going to be there, even if you do apply gypsum. So in our really finer textured soils, like in this area, like the Othello and some other soils along the Chesapeake Bay, gypsum probably won't work very well because it just doesn't, those soils are very fine textured and don't drain well. However, if the frequency of the flooding issue or the salting incursion is occurs more often and is more frequent, there are other strategies that can be employed through crop diversification, through implementing various conservation practices, and soil health practices. So a lot of the same practices we recommend to improve soil health can also be viable for helping us get through some of these, the saltwater or salt incursion issue or salt-affected soil issue. And then some altering of some field management practices, which I think I have a little bit of that on the next slide here. So what are your options? You can move away, move to higher ground. Farmers have been doing that, They just can't farm some of these areas that flood very frequently with salt water. Wetland easements are an option. Shallow tillage or no tillage is actually more beneficial than actually tilling, because you're adding organic matter, you're conserving moisture, you're preventing any capillary movement of salts from deeper in to come to the surface if you have some sort of a mulch in place. We already talked about planting more salt-tolerant crops, and then applying various, working for NRCS. We're in the business of applying conservation practices on the land to help solve natural resource problems. So here's kind of a laundry list, or well, maybe a short list, not a laundry list, of practices that could be applicable for farmers experiencing this problem. But my focus from a plant materials center standpoint is establishing salt-tolerant native plant buffers and or growing alternative crops, which are conservation plants that may have, if we can develop markets, some value-added income. So some opportunities that could potentially exist depending on the geographic area you're in, depending on the markets. For example, establishing a Saltmeadow Cordgrass crop for salt hay, for mulch. Our various plant material centers around the country, well, primarily in the east here, have developed different varieties or different selections of Spartina patens. Some produce more biomass than others. The other thing is if you're getting natural recruitment of salt hay into these fields that are being abandoned, maybe that would be a good enough stand to actually harvest. If it came in thick enough and it was extensive enough. So that's a potential. So salt hay is still a sought-after mulch. The most recent prices I've seen for it, because it's so much not very available, was somewhere in the range of $15 to $18 a bale. So there's opportunities there because people want it and they just can't get it. They're willing to pay a pretty good price for it too. Planting a biomass crop. So our native warm season grasses like switchgrass, coastal panic grass, prairie cordgrass, which grows in a little bit drier site. That particular cordgrass grows in a little bit drier site than Spartina patens and Spartina alterniflora. And then you folks in Delaware especially have probably heard about seashore mallow. the University of Delaware, a former halophyte biotechnology lab, Jack Gallagher and Denise Selskar, are retired, have been retired for 8 years or so. They made extensive collections of seashore mallow, did a lot of testing on its potential use for potential biofuel from the seed, from the oil from the seed, for use as an absorbent, for chopping the stems, for bedding and poultry houses and things like that. But it's a matter of getting that material commercially available, which it hasn't been up to this point. So we've taken a lot of the germplasm that they've tested and collected, and we have it at Cape May now. We're hoping to maybe get it out to the commercial marketplace at some point so it becomes commercially available for use and various applications. And then it's a little bit more of a stretch, but harvesting native shrubs when the stems are dormant in the winter for potential bioengineering applications for stabilizing shorelines, coastal shorelines. Much like we do with the willows and dogwoods in a freshwater stream bank setting, we can do with some of our coastal shrubs. I know Baccharis tends to be somewhat invasive in some areas, but it really tolerates salt well, it tolerates flooding well, and it does have some ability to root from an unrooted cutting, so it can actually be used for stabilization purposes. Most willows aren't highly salt tolerant, but there may be some out there. There may be some stands that might be more salt tolerant than others, so that's worth investigating also. So here's just a few pictures of what I just talked about for the Saltmeadow Cordgrass. It's a weed-free mulch. Demand is still high. We have some varietal selections that we were interested in evaluating. Some advantages are it's an erosion-resistant plant between the wetland and upland, so in that transition zone. It does volunteer naturally when in some areas if there's a plant source or a seed source where coastal farmland is abandoned. It creates a desirable and needed high marsh habitat. We're losing a lot of high marsh because of sea level rise, and our marshes are drowning. There's more open water. So there's actually a lot less high marsh habitat, meaning the patens and the sticulus and Fish and Wildlife is very interested in high marsh habitat for salt marsh sparrow and maybe some other species that utilize that habitat. Again, Delaware's done some trials looking at the harvest yield from Saltmeadow Cordgrass, and generally that's ranged between 3.5 and 6 tons per acre, depending on time of the year of harvest and how many harvests per, how many cuttings per season, and those sorts of things. So there may be even some opportunities to even improve that if we look at specific varieties. Then some of our native grasses that have application for biomass production, switchgrass, coastal panic grass, prairie cordgrass, eastern gamagrass. I already mentioned most of these. We did a native grass riparian buffer study with Ag Research Service out of Penn State back a few years ago. And this was in a freshwater environment, but the top 3 performing grasses in that study, and these numbers you see here are just subjective rankings, from 1 being the best and 9 being the worst. But the prairie cordgrass, the high tide switchgrass, which I talked about, and the eastern gamagrass selection out of New York, out of Big Flats, were the top 3 performing grasses in that freshwater study, compared to big blue, Indian grass were the other entries in this study. As it turns out, the top 3 performing grasses in the freshwater environment also have some level of salt tolerance. I mentioned the high tide switchgrass having pretty good salt tolerance. We're not exactly sure how high eastern gamagrass will go, but we're going to hopefully find that out. And prairie cordgrass is pretty high salt tolerance. So the top 3 performing in the freshwater environment are also have application for saltwater environments. So you talk about establishing buffers with native warm-seeded grass species, and I even provided a short list of some wildflower species that could be incorporated for pollinator habitat, depending on how the buffer is being used or not used. If it's just providing ecosystem services, you might want to have the wildflowers in there. If you're harvesting the buffer or harvesting a field of native grasses, you might want more of a pure stand of native grasses for increasing the biomass production. But things like goldenrod, primrose, New York aster, rose mallow, seashore mallow, these all have pollinator value as well as have some salt tolerance. And also, you have this this buffer here, and I'm not sure if this was intentionally planted. This was, Danny, this was on one of the farms that the study was done. But it was right along the ditch is right over here between the road. You see the gravel road and the field. We have this buffer, which is primarily eastern gamagrass, and I'm not sure it was intentionally planted or whether it came in naturally, but it was left go, so it's right next to the ditch. So you talk about having something actively growing next to the drainage ditch to improve carbon sequestration. This is another potential option of doing something like this. This is only about, I don't know, maybe 15, 20 feet wide. Compare that to not far from where I took that picture. This is a drainage ditch right next to the soybean field. I actually checked the salininess. I think this was back in late September, early October, and it was about 15 to 16 parts per thousand. So it's pretty brackish. So obviously, if you get a storm event where you have water coming up from the tidal river, could potentially impact the soybean field because there's no buffer, there's no protection there. So that's Spartina alterniflora. I haven't seen too many places where I see Spartina alterniflora, which is the dominant grass in the tidal marsh, growing right next to a soybean field. But this was a perfect example of that occurring. And then we also did a study looking at if we could control Phragmites, spray Phragmites, try to get it suppressed, come in with a planting of native grasses, if we would see any grasses perform to maybe prevent the reinvasion. Obviously, we're not going to totally prevent reinvasion of Phragmites, but we thought, well, if we can diversify a Phragmites stand, that would be a positive thing. It's probably the best we can do in some circumstances. So in that particular study, which the site conditions were, from a hydrology standpoint, were a little on the wet side, but our three best performing materials, plant materials, was again the switchgrass, the prairie cordgrass, and the rose mallow, not the seashore mallow, but the hibiscus, the rose mallow you see growing with the big flower, the big hibiscus-like flower in the marsh. Actually had the best survival because the site was pretty much on the wet side. The eastern gamagrass doesn't like to be growing in pure, saturated soil conditions for a very long period of time. It will tolerate flooding, but not growing in standing water for a long period of time, so it didn't perform very well. But there are other species that could potentially be used in this application, that being seashore mallow, the giant cordgrass, the Spartina sinusoides, the real tall one, giant cane, which is a native material that has about the same height as Phragmites does. High tide bush and baccharis are other potentials. Now, here's another example of this was a farm field here that was abandoned, and you have the Phragmites right at the edge of the field, and it's standing there like an army ready to invade the field. But we had some naturally occurring native warm season grasses coming in on their own, right between the Phragmites and the field, the former crop field, that being coastal panic grass. So we didn't actually use coastal panic grass in this particular study, and that wasn't the study site, actually. This was just an observation. But coastal panic grass is very closely related to switchgrass, so switchgrass might perform the same function. Seashore mallow. So again, it's a unique plant. Flowers they live one day. They're either pollinated by insects or they self-pollinate, and then they drop off. It's an obligate wetland plant, but it will grow in a drier site. The stems can be harvested and ground for absorbent material, for kitty litter potentially, for bedding in poultry houses. The seed can be pressed for oil. So there's a lot of different potential uses. Again, it's developing the commercial market for it. Can be seeded, no-till. Can be seeded in a conventional till setting. Here's that's Denise out standing in her field. and the flowers. You can see the good flowers, and then a pretty solid stand of rose mallow, or seashore mallow in this case. And they've worked with the USDA has a lab out in Peoria, Illinois, that looks at alternative uses of materials, and they've done some publications on biodiesel and ethanol production from this plant, as well as biodegradable absorbent materials. So there are potential opportunities. You kind of, I guess I'm trying to get you to think outside the box a little bit. And then here's the dormant stems that could be harvested for bioengineering applications. This is a harvesting in the winter chainsaw, placing the dormant stems on an eroded bank, or sticking cuttings in the bank and having them root from an unrooted cutting. And it's interesting. We've studied the roots a little bit of some of these species, and depending on the site conditions, whether what kind of water and hydrology you have, the grasses in particular will develop different types of roots depending on the amount of saturation. So the eastern gamagrass, for instance, has a high level of parenchyma roots, which allows for oxygen exchange in saturated soil conditions. Switchgrass also forms those in a more saturated site. And then the finer fibrous roots are for nutrient uptake. So, if we had the opportunity to plant these buffers and actually harvest them, we could actually be taking nutrients off. So if, in fact, we're getting legacy nutrients coming from some of these fields, if we had a good buffer in place that might be able to absorb or intercept some of the nutrients that are coming off the field, that would be a positive thing. And just kind of schematically, looking at this whole thing as a holistic system, where you have your ocean or your bay, and then you have your wetland and tidal marsh area, and then you either have a natural buffer or a managed buffer. And so these buffers take care of most of the storm events, but occasionally you'll have a more severe event, which is the red, which may impact the terrestrial ecosystem, the crop fields, cropland, infrastructure, that sort of thing. But having this either natural or managed or a combination of the two serves a good role from an ecosystem services standpoint and even from a potential income standpoint. Just one other thing this is kind of related to. There was a movement in Florida called raisingfields.org. It was a nonprofit. They were doing education on growing plants in raised bed situation or raised fields. This is kind of analogous to that in New Jersey. They're starting to apply dredge, or there's a few producers, a few operators who are getting permits to put dredge on their land to have a place for it to go. When they dredge the intracoastal waterway behind Ocean City, New Jersey, they're doing extensive testing to make sure there aren't contaminants in that material. Then they're trucking it out to a couple farms not far from where the Plant Material Center is located. They're putting it in a containment facility temporarily, allow it to dewater. Then they're mixing it with some of the native soil in the area, existing soil, and then they're spreading it on the fields, spreading it on the land. And so in the process of doing this, one of the first questions they asked us was, okay, well, we got this material. It's highly saline. It turned out it's pretty highly acid, too, very low pH, because there's sulfides in the material. What do we plant? Well, we did a trial. We planted beach grass, Spartina patens, and prairie cordgrass. And we planted the plants dormant last December, monitored the site through the growing season. The Saltmeadow Cordgrass, the Avalon variety, which the Cape May Center has released, really did the best. I mean, it didn't seem to be stressed. The beach grass was somewhat stressed, but it still had very good survival. The Spartina pectinata, the prairie cordgrass, was somewhat stressed, but it did okay too, pretty well actually. So here we go. Here's a shot of the site not long ago, maybe a month or so ago. But this is what the material looks like once it's spread. So it's really sticky and really fine textured, gooey. But it dries out, and it got dry towards the end of the summer when we had that drought period. But you can see the Spartina patens, the Saltmeadow Cordgrass, did very well. The prairie cordgrass did, not quite as well, but not bad. And then the beach grass was stressed a little bit because the beach grass likes to be in pure sand, not so much in a finer textured soil like this material was. So the folks are maybe interested in potentially growing some of these conservation plant species on this material and actually selling it commercially for restoration projects, for living shorelines, for dune stabilization, and that sort of thing. So it's a beneficial use of a material that's considered a waste product. So why grow conservation plants for coastal environments for potential income? Well, diversification, alternatives to row crops or vegetables if the markets exist or if you can develop the market. Some of these would provide off-season income. So when there's nothing actively growing, you're harvesting dormant. Potential income from limited resource farmers. Developing new markets, for bioengineering, for biomass production, for agroforestry applications. Plant material centers can provide starter materials for materials that we work with. And then provide technical support and production information to assist the grower in planting and harvesting and all those things with managing those plant materials. So back in 2008 or so, when the big biofuel thing was really hot, there was a chief scientist with the NASA Langley Research Center that was really promoting halophytic crops for biofuel applications. And I just borrowed one of his slides where he basically said that, conventional wisdom, traditional wisdom is that salt water is bad for agriculture. It's bad, we can't do anything with it. And 98% or 97.5% of the water on the earth is salt water. His view was, saline agriculture has potential. It's viable to desirable alternative to conventional ag. Obviously, it's going to take time to convert over, but it's not all doom or gloom, whatever. Here's an example of in the United Arab Emirates in the Middle East. They actually harvested glasswort or salicornia to produce biofuel, and they actually in January of this year, January 2019, they actually flew from United Arab Emirates to Amsterdam. The jet fuel was made out of the salicornia. It was the world's first flight using biofuel, primarily biofuel. I think it might have been mixed with something else, but it wasn't 100%, but it was a majority of it was biofuel. Also in the Netherlands, the restaurant industry is interested in this plant, and I was told that they can gross about $30,000 to $35,000 on roughly 2.5 acres of salicornia for the restaurant industry. So, and this is a production field of the salicornia. So it's not growing in a wetland; it's growing in an upland, but it's irrigated with salt water. And this is about, like I said, about 1 hectare in size, and it was seeded. So the seed is like powder. It's very, very fine. And the innovator or entrepreneur that did this wouldn't divulge some of his trade secrets, I guess, of harvesting and cleaning the salicornia seed. But anyway, he's promoting this plant, and the restaurant industry is utilizing it. They're utilizing it in salads. They're utilizing it in soups, filler material for other products, food products. I'll tell you what, though, their blood pressure must be awfully high because that stuff is really salty. So anyway, as far as technical resources related to this subject, the Climate Hubs can serve as a resource. The Plant Materials Program website, particularly with coastal applications, our Cape May Plant Materials website. And then some of you may not realize that there's a group out there now. It formed in Pennsylvania a few years ago, but it's the Association of Native Warm Season Grass Producers, and they're promoting native grasses for biofuel, biomass, bedding material, all those various uses. So they have some information on their website about producing the material and marketing it and that sort of thing. So how did I do on time? I missed the 10.
No,
Oh, okay. All right. So thanks for listening, and hope you learned something.